Siddika, Harsha, and Abdul Hamid also attends different class. I have turned the focus mode on, so you don't have to worry. Your video will not be getting recorded. Neither any of the participant can see your videos. So once you are ready, please keep your cameras on, Siddika and Harsha. Okay.
Okay, sir, 1 second.
So I think we ended with yeah.
Can I turn my camera on in the next class? I don't have my abaya hijab right now.
Not a problem. Harsha?
Yes, sir, just a second.
Okay, fine. So in the last lecture, we completed, okay, fine. So we have seen delta U is equal to Q plus minus the external delta V, and we have seen the different cases also. I hope all of you are comfortable with these different cases. And yeah, there is one case that we started, that is when we measure the heat change at constant external pressure, then we call that heat as enthalpy. And this enthalpy is the thing which is going to be used in the complete thermochemistry. Okay, so we will first of all see what is enthalpy. Please write the topic enthalpy. Now, okay. Now, enthalpy, it is the heat involved during a change when external pressure is constant. External pressure is constant. Okay. Also, one more thing that is very important is that enthalpy is given by H, and we will not be measuring the exact enthalpy or the absolute enthalpy. The heat involved during a change, that means we are always talking about delta H. We are always talking about delta H. That means the heat involved when the pressure is constant, that is QP, it is equal to delta H. There's a bit of derivation with this, but you don't have to worry about that derivation. It is not going to be asked, neither it is very much useful in the further topics. That is why I'm leaving out the derivation, and it is simple derivation. Even if you look at the book, it will be very easy to understand. But we have seen we have just named it, that heat involved during a change when external pressure is constant, that is enthalpy. And if you observe the chemistry lab, in chemistry lab, you do all the reactions under atmospheric pressure, right? And atmospheric pressure is always 1 atm. Now, when it is always 1 atm, then it is always constant, right? The atmospheric pressure is not changing. External pressure, please remember. You may say that, sir, when we heat something which is fixed, which is having a rigid volume, the pressure will increase here, right? So that internal pressure will increase, internal pressure will change, but the external pressure, it is always equal to 1 atm. That is the thing that you have to keep in mind. External pressure is always how much? Tell me, guys. External pressure in the lab will be always 1 atm. Okay? We are not talking about the internal pressure here. So this is the enthalpy, and in chemistry we'll always be talking about enthalpy. Okay? We'll be always talking about enthalpy. Please write here. So this QP, it is equal to delta H, and we also know that delta U, it is equal to what? Tell me, guys. Delta U, it is equal to Q plus, here I can write minus P external delta V. Correct, guys? You can please tell me.
Yes,
Correct.
sir.
And Q with the, if I write QP here, that means at constant pressure, delta U will be equal to, this Q will be what? Delta H minus P external delta V, and from here I can write delta H will be equal to delta U. This minus Px will go there, it will become plus Px plus P external into delta. Now this is the formula that we have to remember. ये कुछ नहीं है ना? I hope you can see that it is just the, if you remember delta U, it is equal to what? Delta U, it is equal to the previous form is Q plus W. It is nothing but a changed form of Q plus W. W is minus P external delta V, and when the pressure, external pressure is constant, we can write Q as delta H, and then you rearrange, you will get delta H is equal to U plus Px delta V. Now let me know once you're done.
You're done.
Is everyone done? Let's see, I have
Yes.
students here. Okay. Mariam, Martin. Why are you guys late, Mariam and Martin? Mariam, am I audible? Martin, am I audible?
Yes, sir.
What happened? Why are you late?
I was praying.
Praying Maghrib.
Yes.
What time is Maghrib these days? What time is Maghrib?
6. These, I guess.
6:15.
Yeah.
6:15 class starts at only half an hour after Maghrib. Maghrib, so you can start praying Maghrib just after the azan, na, Mariam? फिर चाय नाश्ता हुआ? जी मरियम. After Maghrib, you had snacks?
No, sir.
No. अच्छा मैम, फिर इतना लेट कैसे लग गया? आप क्या पढ़ने लगे? सूर्य यासीन पढ़ने लगे आप? हाँ, जल्दी आइए,
I was
ठीक है मरियम?
talking. Yes.
You are talking to?
I was talking to someone, so.
There is someone also. ठीक है भाई. Okay. Martin, what happened to you?
Yes, sir.
Why are you so late? जल्दी तो कॉपी
Oh,
स्टार्ट
sorry.
करेंगे ना? Sorry. Sorry. It's okay. What should I say? If you say sorry, it's okay. हाँ जी. मरियम आप लिखिए, है ना? चलिए जल्दी जल्दी लिखिए. चलिए खैर ठीक है, आप लोग लेट मत कीजिए, ठीक है ना? हाँ, हमको डांट मत करनी है, आप लोग लेट मत किया कीजिए. Don't talk to someone, okay Mariam?
Yes, sir.
When's class timing? Up class में. Also Mariam and Martin, you have to keep the cameras on during the classes, ठीक है? September आ चुका है. I think it's time to be a bit more serious, है ना? So even though, see, I understand completely that when you are doing online classes, you may be tempted to talk to someone, for example, है ना? And you may be tempted कि मान लीजिए आपको कोई छोटा कजन आ गया, तो कजन आ गया, उसके बाद बंदा ऐसे बच्चे से खेल भी रहे हैं आप, है ना? साइड में आके आप इधर परेशान कर रहे हैं, उससे बातें भी कर रहे हैं. इधर हम कभी आपका नाम ले तो यस सर, ऐसा आप बोलते रहे, हाँ सर आई एम प्रेजेंट इन द क्लास. So those type of distractions should not be present from now on. Is that clear? So that is why you keep your cameras on. और साथ में आपकी मदद करने के लिए हम जनरली कैमरा ऑन नहीं रखते, because sometimes I feel that I may be distracting the students, है ना? कि स्टूडेंट्स मतलब वो देखने लगते हैं सर के घर में क्या क्या है, सर के घर में ये वाली घड़ी है, ठीक है? तो आई डोंट वांट, सो आई हैव सीन दैट ओके आई कैन डू समथिंग ब्लर. अरे सर को कोई चाय लाके दिया, है ना? तो बच्चे आते टाइम उसमें डिस्ट्रैक्ट होते रहते हैं. दैट इज व्हाई आई जनरली डोंट टर्न माय कैमरा ऑन. बट आपका साथ देने के लिए आई हैव टर्न माय कैमरा ऑन आल्सो. तो मरियम एंड मार्टिन, है ना, यू हैव टू कीप योर कैमरास ऑन. आपको सिर्फ मेरा चेहरा दिख रहा होगा, दैट इज बिकॉज ऑफ प्रीवियसली ऑफ द अदर स्टूडेंट्स. एंड जब आप कैमरा ऑन करेंगे तो सिर्फ उस टाइम आपको, मतलब हम सिर्फ आपको देख सकते हैं, बाकी कोई नहीं देख सकता है, ठीक है? इज दैट क्लियर मरियम?
Yes, sir.
लिख दिया आपने?
Yes.
चलिए मार्टिन, यू आर डन राइटिंग?
Yes.
Yes, fine. See here, guys. So we have delta H is equal to delta U minus, sorry, delta U plus P external delta V. And according to the ideal gas equation, we have seen this ideal gas equation previously also. According to ideal gas equation, we have PV is equal to nRT. Sorry, I was thinking about something else. PV is equal to nRT, right? Now, from here, what we can write? We can write PC. The pressure, it is not going to change. The external pressure is not going to change, right? So I can write P V, let us support A, it is equal to, let us take a reaction first of all. We will take a reaction. Okay. So reaction we have we have A to B. A to B. So this is reactant and this is the product. Now here I'm writing only A, but please remember that when I write only A doesn't mean that we have only one chemical species. A represent all the reactant, B represents all the product. Is that clear? A represents all the reactants and B represents all the product. Clear, sabko? Okay.
Yes.
When I write PVA, it is equal to NART. I'm keeping the temperature same and I'm also keeping the pressure same. So volume A, it is equal to NART. And for the product, we will write P, volume B, it is equal to NBRT. Number of moles of the product. Okay, and this is number of moles of the gases. Now I can write PVB minus PVA. It will be equal to NBRT minus NART. Now P, I can take common VB minus VA. It is equal to, I can take RT common, and this will be NB minus N. If I talk what is volume B minus volume A, that is the change in volume while going from reactant to product. So I can write this as P delta V. This will be equal to RT, and NB minus NA, it is nothing but the change in the number of moles of, please remember, gases, change in the number of moles of gases when I go from the reactant to product. So I can write it as delta NG. N means number of moles, G means gases, RT. Is this clear? Yes or no? Please tell me.
Yes, sir.
P delta V. Okay. Now I can write delta H, it is equal to, with some spaces, delta H, it is equal to delta U plus delta NG RT. Let me know once you're done, guys. Let me know once you're done writing. By the way, Harsha, how is your brother?
Yes, fine, sir.
He's fine. उसको ठीक लग रहा है वहाँ अकेले?
Yes.
कोई वहाँ पे ऑलरेडी मतलब एग्जिस्टिंग लोग हैं उसके मतलब जेएनयू में?
Yes, sir. He has a friend from here.
Actually, he has a friend from here. Same BTech only.
Yes, sir. His roommate.
Oh, nice. He got hostel in JNU.
Yeah, he got some.
Done, sir.
Okay. So, does politics interest him, Harsha?
No, sir.
I hope it stays that way at least for the 4 years. Because JNU has a lot of, I mean, it influences a lot of people there. And in a good way or a bad way, I cannot say, but it does influences. And in however way, studies do get hampered a bit sometimes if the student is not careful. Okay. See here. So here we have delta H. What is delta H? If you remember, delta H, it is the energy change. Please don't write C here. Please don't write anything. It is the energy change at constant pressure. Energy change at constant pressure. Okay. Pressure. Energy change at constant pressure will be equal to, what is delta U? What is delta U? What is delta U? See here, you will have somewhere. In volume, it is equal to 0. That is the energy change or the heat change in constant volume. Can you see that?
Yes,
Right
sir.
here. Delta U is energy change or heat involved. Energy change at constant volume plus delta Ng. It is the change in number of moles of gases. Change in number of moles of gases. This is important. You have to only include gas because we were taking into consideration only the gaseous molecules in the ideal gas equation, right? Then we have R into T. So what is R? R value will be 8.314 into the temperature, and this temperature should be in Kelvin. Temperature in Kelvin. बिल्कुल प्रॉपरली इसको ऐसे लिखिए, अदरवाइज यू विल बी कंफ्यूज. फिर आप पूछते हैं ना, सर व्हाट फॉर्मूला टू यूज, वो यहाँ से ठीक है कि आपको क्या दिया, व्हाट इज एक्चुअली, दे विल नेवर गिव यू द एंथैल्पी इज दिस मच, द डेल्टा यू इज दिस मच. दे विल नेवर गिव यू दैट वे. They will never give you the number of moles of gases in reactant is this much, product is this much, or delta Ng it is equal to this. They will give you the reaction. You have to find out, okay, how many number of moles of gases there, and then you have to find out whether they have given the energy change at, whether they are talking about constant volume or they are talking about constant pressure. Okay, so all of these things you have to decode from the word problem. Please write this down. Let me know once you're done, then we will do a problem. Please let me know once you're done writing.
Done, sir.
That's it.
Write the question. The reaction of cyanamide with oxygen. The reaction of cyanamide with oxygen. This oxygen gas gives out heat at constant volume which is measured to be minus 742.7 kilojoule per mole at 298 Kelvin. Calculate the enthalpy change for this reaction. Now they have also given you the reaction. ठीक है ना? Please write the reaction because obviously you will not be knowing the reaction. Please write NH2CN. NH2CN plus 3/2 O2 gas gives N2 gas plus CO2 gas plus H2O. Please here guys. कर लेंगे हर्षा, अब्दुल हमीद, सिद्दीका, Mariam. Mariam and Martin, why are your cameras not on? Yes, Mariam and Martin, what happened? Thank you. Martin? Yes. What happened when your camera is not on? Yes, Martin.
Yes, sir.
Why is your camera not on?
Camera you should
Sorry?
on camera.
Yeah, camera. Why is your video not on? The camera on the video not on. Why is your video not on? Now you have to talk to your father. I mean, your father said that you will turn your camera on, and it is not showing anything. No, it's there. Fine. Mariam. Mariam, what happened?
Sir, can you give me a minute?
Okay, I'll give you a minute. No problem.
I'll switch it on.
Yeah, no problem. Okay. What about what happened? Harsha, Abdul Hamid, you are able to do this? क्या ख्याल है?
No, sir.
No. ठीक है, देखिए. Please here, guys. What about you, Harsha?
Yes, sir.
ठीक है. See here. Slowly, है ना? We'll go slowly. See, reaction of cyanamide with oxygen gas give out heat at constant volume, which is measured to be minus 42.7 kilojoule per mole. So what is this value? If I talk about the equation that we have just seen, na? So this is the energy change at constant volume. Can you see that, all of you? Yes or no, please tell me. दिखा सबको? ये दिखा? This value, it is what? It is the heat at constant volume. That means it is the energy change at constant delta E. ठीक है? सबको दिखा? लिखने की जरूरत नहीं है अभी, ध्यान से सुनिए. Delta U they have given. They have given delta U, it is equal to minus 742.7 into 10 to the power 3 because kilojoule units. ठीक है ना? Joule. Units will be in joule. Okay, joule per mole. Is this clear? Yes or no? Please tell me. यहाँ तक कोई दिक्कत?
Yes, sir.
Temperature they have given as 298 Kelvin. Temperature is equal to 298 Kelvin. They have given in Kelvin already. Now we have to calculate the delta Ng, right? Delta H they have asked. Delta H is equal to how much? We don't know. They directly asked what is the enthalpy change, right? They're asking for delta H. You have to calculate delta Ng, number of moles of gases. So number of moles of gases in product minus the number of moles of gas in reactant. So let us look at the product, number of moles of gases. So they have given a completely balanced chemical reaction. You don't have to worry about this. Here we have 1 mole of N2, 1 mole of CO2, and please remember, H2O will not be a gas. H2O at 298 Kelvin, it is a liquid. बात सही है हाँ या ना? H2O 298 Kelvin is 25 degrees Celsius. So H2O at 25 degrees Celsius will not be gas, it will be a liquid. Correct guys? क्या ख्याल है? ठीक है? So
Yes,
number
sir.
of moles of product will be equal to how much? We have 2 moles of gases in the product. And number of moles of gas in reactant, gas. We will not consider this because it is दिखा सबको हाँ या ना? Got this? Yes or no? Solid?
Yes, sir.
ठीक है. and 3/2 moles of O2. That means minus 1. अरे लिखने की जरूरत नहीं है अभी मार्टिन, अभी देखिए आराम से. Minus 1.5. ठीक है, अभी ध्यान से. 3/2 is 1.5, so this will be equal to how much? 0.5. Now we know that delta H, it is equal to delta U plus delta NGRT. Clear है हाँ या no? So now you can plug in the values. You can plug in the value, no? अच्छा, R की values you know, right? R is equal to 8.314. If you want the unit, it is joule per mole per Kelvin. ये आप कहाँ से क्लास कर रही हैं मरियम? हाँ, आप हमको डराना चाह रही हैं? आप हमको डराना चाह रहे हैं? वो उसके पीछे आप लोगों को नहीं दिख रहा है, मरियम के पीछे वो पूरा जिम का सेटअप है, पता है? वो हमको डराना चाह रही है. मास्टर, तुम ज्यादा हमको फोर्स मत करना, है ना? That's in your room.
No, that's my dad's. It's like
अच्छा.
study room.
अच्छा, it's like study room. Plug in the values and tell me what's the answer that you are getting. Understood all of you? Yes or no? Please tell me how to extract the values or the data from the question. Yes or no?
Yes.
ठीक है सबको, है ना? So you have to read the problem very carefully, that what they have given and what they are trying to give you. Because अक्सर क्या होगा करना? Read the question, you will say क्या पूछा है भाई? I don't even understand. Get the answer once you get it. हाँ जी, कितना आंसर आया? किसी का आया नहीं आया? Once you get the answer, send it on Zoom chat. मार्टिन क्या कर रहे हैं आप? कैलकुलेट कीजिए. Show me your work ना Martin. What you have done
Yes,
till now?
sir.
Show me your work.
Still doing, sir.
Show me your work. Show me your work. What you have written till now. show me like this, ऐसे. Like this, to show me. इस तरह का. Mine will come blur because कुछ लिखा ही नहीं है, अभी ये लिख रहा है. क्या आंसर नहीं आया? किसी का आंसर आया? वेट वेट. -318. I don't think so, हर्षा. कुछ तो गलती की है आपने. Let's see, -742.7 into 10 to the power 3 kilojoules, and plus we have 0.5. 0.5 means 1 by 2. 1 by 2 into 8.314 multiplied by 298. ठीक है. So this will be -742.720 plus half of 8.314. 0.5. Multiplied by 8.314 multiplied by 298 is equal to 1238. If you approximate, it will be 1239. So how much value did you guys get? Tell me. 42700 minus 1239 is 741461. Joule per mole. And if I write it, it will be -741 point. I can approximate this to 5 kilojoule per mole. Harsha, where did you get this one? How much of you got it as 1239?
So I got like kind of decimal.
Sir, I got 1238.
123. That's fine. 123, it is fine. So if you subtract, you will get approximately 740 minus 741. I have approximated this as 500. So it will be 741.5 kilojoule per mole. Harsha, where did you do the mistake?
So in the first step, I took 2 instead of 8.
2 instead of 8. What do you mean?
So
Where?
the multiplication, I did it wrong.
Here.
Yes.
Oh. चलिए. Please copy this down quickly. Martin, आपका कितना आया था? कुछ बोल रहे थे आप?
Right answer.
No. How much did you get? You were saying something now?
Yeah, I mean, I was doing the 7 minus 742.7 into 10 raised to 3 plus 123, 1238.7.
Something like that. So when you have point and 10 to the power 3, you just try to multiply the powers of 10 so that you can do addition and subtraction. And so where is your brother nowadays, Martin?
Oh, he's in Bangalore, sorry, Karnataka.
Karnataka. Engineering?
Yeah, he's in Manipal or something.
Okay. CS, computer science. Computer science. Yes, Martin.
Yes, sir.
Computer science. What are you doing? Huh?
Yeah, I'm here. Yes.
No, you're not here. I can fine. See, I have good eyes, so you be on the same tab, okay? You don't need to change the tabs. Is that fine, Martin?
Yeah.
Okay. Here, guys. Now, next thing is that we have seen that delta H, I can say that it can be equal to two things. No need to write this. Please see here first of all. Please see, don't write. Delta H, it will equal to, we have seen just now, it is equal to delta U plus delta Ng RT. And it is also equal to delta H, it is also equal to delta U plus P delta V. Plus P delta V. Now let us suppose when no gas is involved in a reaction, then we can say delta Ng will be equal to how much? 0. Correct? Yes or no? Please tell me. If the gas is not involved in the reaction, delta Ng, I mean there is no gas in the reactant, no gas in the product also. Or delta Ng, it is delta Ng, not I will write number of gas in the reactant, it is equal to the number of moles of gas in the product. Now in this case also delta Ng will be equal to 0. Is that clear? Yes or no, please tell me.
Yes.
Okay. Therefore,
Yes.
I can write delta H will be equal to delta U. Because when Ng it is equal to 0, it will multiply with RT, this whole thing will become 0. And we will have delta H, it is equal to delta U. Is that clear? Yes or no, please tell me. Okay. हाँ जल्दी बताएं. Got it? Yes or no?
Yes, sir.
ठीक है. Right, next, when the reaction is done, in closed vessel. So when we are doing the reaction in closed vessel, please remember very carefully, and we have a rigid boundary. If we have a rigid boundary, so the boundary cannot expand. Neither the boundary can, neither it can expand nor it can contract. So the volume will be equal to 0. The volume change, there will be no change in the volume, right? Delta V will be equal to 0. Therefore, we can write delta H will then also be equal to delta U. Are both these conclusion clear? Yes or no? Please tell me, guys. याद रहेगा?
Yes, sir.
Hamid, Martin, Mariam. याद रहेगा?
Yes, sir.
Okay. Write this down. that clear? Yes or no? Please tell me. आगे बढ़े, सबने लिख लिया? Done
Yes.
writing?
Yes, sir, 1 minute.
1 minute, जल्दी लिखिए.
Okay, sir.
And all of you, please see here, guys. All of you, please see here. Let us suppose we have a container in which we have a very less amount of volume. Liters. You can suppose it is what, 2 liters, 3 liters, and whatever you suppose. And then we have a very large container. And here we have large amount of water. Here we have large amount of water. This whole container is having water. Now tell me, right now both of these are in 25 degrees Celsius. This is also in 25 degrees Celsius. Okay. I want to take both of them from 25 degrees Celsius to, let us suppose, 80 degrees Celsius. Okay. This also from 25 degrees Celsius to 80 degrees Celsius. Now you tell me, guys, this will require some Q1 heat. I will heat it, then only it will go to higher temperature, correct? Now, without heating, it will not go. And this will require Q2 heat, which will require higher heat. Tell me, guys. Q1 or Q2?
Sir, Q2.
Q2, all of you agree, right?
Yes, sir.
Q2 will require more heat than Q1. Q2 will require more heat than Q1 in order to go from 25 degrees Celsius to 80 degrees Celsius, 25 degrees Celsius to 80 degrees Celsius. Now, when it is in 80 degrees Celsius, even though both of these containers, they have the same temperature, both of them are going to have the same temperature. One is having 80 degrees Celsius, the other is also having 80 degrees Celsius. But the amount of heat in the larger container, let us say that this is A container, this is B container. The amount of heat that the larger container is holding, that is more. B is holding more amount of heat, na? Where did the heat go? You gave more amount of heat to B. All of that heat went into the B container. So B is holding more amount of heat, right? And this is known as heat capacity of the substance. So I can say that the heat capacity, the capacity of holding heat is greater in B than A. Ye clear hai yaar? Correct, all of you? Is this clear?
Yes, sir.
Yes. Now we are going to talk about the different types of different heat capacity and the heat capacities of different substances. Okay, so you will write the topic. Please write the topic heat capacity. Given by C. Okay. First of all, the heat that you are giving will be directly proportional to the delta T. It will be directly proportional to the amount of change in the temperature. If you want to change more, if you want to change temperature to, if you want to change the temperature 5 degrees Celsius, then you require less heat. If you want to change the temperature 20 degrees Celsius, you will require more heat. So Q is directly proportional to delta T. Next, you will see, I will write a proportionality constant and I will give a equality sign, a proportionality constant that will be C delta T. So what will be C? C will be equal to the Q divided by delta T. C will be equal to Q divided by delta T. Please write this down. Okay, now see here. What is heat capacity? Heat capacity, it is the heat required by a system to increase the temperature by 1 degree Celsius or 1 Kelvin. Very easy to remember. Whenever you have to define, please remember very carefully, whenever you have to define a proportionality constant, this is a proportionality constant, right? This proportionality constant, it is in the RHS, right hand side. So right hand side वाले को आप 1 कर दीजिए. Delta T है ना, right hand side में variable, इसको आप कर दीजिए 1. So that is the heat capacity. Please see, when delta T it is equal to 1, Q it is equal to C. हम ये कह सकते हैं ना, heat capacity is the heat required when change in temperature it is equal to 1 degree Celsius या 1 Kelvin. आसान है, समझ में आया सबको? heat capacity, it is the heat when delta T it is equal to 1 degree Celsius. So this is how we define all the proportionality constant. ठीक है, please write here. Heat capacity is the heat required by system to increase the temperature by 1 degree Celsius or 1 Kelvin. अच्छा, ये चीज पता नहीं आप लोग को ये मालूम है या नहीं. 1 degree Celsius, guys, please listen. 1 degree Celsius or 1 Kelvin, when we talk about change, जब हम change की बात करते हैं ना, then 1 degree Celsius and 1 Kelvin it is same. क्या लगता है आपको, सही बात है गलत बात है? क्या 1 degree और 1 Kelvin same होगा? Is 1 degree and 1 Kelvin same? हर्षा, अब्दुल हमीद, मार्टिन, मरियम,
No, sir.
ये बताइए. 1 degree और 1 Kelvin तो सेम नहीं है, लेकिन जब चेंज की बात करें तो ठीक है, आप लोग लिखिए इसको, फिर हम बताते हैं ना कैसे. when we talk about change, 1 degree and 1 Kelvin is same. You write this down.
Sir,
डन, ठीक है. ऑल ऑफ यू डन? मरियम हो गया, ठीक है. ठीक है.
No,
If
I'm
I
not
go
done, sir.
अच्छा, what are you writing, Martin?
They work, sir. Right. Right answer.
Please see here. I am going from, please see, na, don't write 0 degree Celsius to, let us suppose, 5 degree Celsius. ठीक है, 0 degree Celsius to 5 degree Celsius. What is the change in temperature? 5 degree Celsius. ठीक है सबको, आया ना? सही है. अच्छा, 0 degree Celsius means how much Kelvin? 0 degree means
273.15.
273 Kelvin. And 5 degree Celsius means how much Kelvin? 5 degree Celsius means how much Kelvin? करना पड़ेगा क्या?
1360.
How much? अच्छा,
1365.
1365 Kelvin. How? Abdul Hamid,
yes, sir.
how much is 5 degree Celsius in Kelvin scale?
So 278.
क्या हो गया है? 278 guys. 278 Kelvin ना. अभी बताइए delta T it is equal to how much? Change in temperature कितना है? बोलो भाई, कितना है? 75 Kelvin still ना. Even though degree absolute temperature, if I talk about degree Celsius and Kelvin scale, absolutes are different, but the change is still the same. ये दिखा आप लोग को, हाँ या ना? याद रहेगा?
Yes, sir.
ठीक है, वो होता है इस वजह से. इफ आई टॉक अबाउट एक्चुअल स्केल की अगर हम बात करें ना, अगर हम ये मान लीजिए दिस इज स्केल, राइट, एंड देन वी हैव अनदर यूनिट हियर. हियर इफ यू हैव 0 1 2, सेम यूनिट, एक यूनिट जो है ना इतना ही होता है. केल्विन का यूनिट और डिग्री का यूनिट की स्पेसिंग सेम होती है, बट 0 is 273 here, this will be 271, this will be 274, this will be 275. ठीक है, तो ये स्पेसिंग क्या है, बराबर है किसमें? डिग्री सेल्सियस में एंड केल्विन केस में. ठीक है, दैट इज व्हाई the change in the temperature for degree and Kelvin, both of them are same, but absolutes are going to be different. Is this clear? Yes or no, please tell me guys. समझ में आया सबको? याद रहेगा?
Yes.
मरियम,
Yes,
अब्दुल
sir.
हर्षा, ठीक है, चलिए। नाउ राइट हियर, इसको लिखने की जरूरत नहीं है, याद कर लीजिए, काफी डेल्टा टी सेम रहता है, ठीक है। Now we were talking about heat capacity. और हीट कैपेसिटी के बारे में हमने बोला, हीट कैपेसिटी इज द हीट रिक्वायर्ड by the system to increase the temperature by 1 degree Celsius or 1 Kelvin. ठीक है, सुनिए, ध्यान से सुनिए। If someone asks from here that what is the heat capacity of water, अगर हमें कोई पूछ लेता कि भाई heat capacity of water बताओ कितना होगा, then it will be very difficult to answer because कितना water है ना, एक मग पानी लेंगे तो उसको 1 डिग्री सेल्सियस या 1 केल्विन टेम्परेचर इंक्रीज करने के लिए जो हीट रिक्वायर्ड होगा that will be less. But if I take 1000 liters of water, then obviously the heat required to increase the temperature by 1 degree Celsius for 1000 liter will be very high. That's clear. Now that is why what we need to define the quantity also. So heat capacity को हम दो तरीके से measure करते हैं. One is known as specific heat capacity. Heat capacity. और दूसरा होता है molar heat capacity. Molar heat capacity. ठीक है, specific heat capacity it is related to mass, यानी कि ग्राम से रिलेटेड है ये। molar heat capacity it is related with moles, that is number of moles को n से डिनोट करते हैं तो moles हो गए, ठीक है। अच्छा, specific heat capacity को, इसको तो हम लोग लिखते हैं इस तरह से, molar heat capacity is written as Cm, ठीक है। और स्पेसिफिक हीट कैपेसिटी के लिए ऐसे कोई खास टर्म नहीं है, स्पेसिफिक हीट कैपेसिटी को आई विल टॉक इट एज SHC, स्पेसिफिक हीट कैपेसिटी। मोलर हीट कैपेसिटी को आई कैन शो इट बाय Cm, याद रहेगा। क्या सुनिए, व्हाट इज स्पेसिफिक हीट कैपेसिटी? इट इज सिंपली द अमाउंट ऑफ हीट रिक्वायर्ड टू इंक्रीज द टेम्परेचर बाय 1 डिग्री सेल्सियस और 1 केल्विन फॉर 1 ग्राम फॉर 1 ग्राम ऑफ अ मॉलिक्यूल और सब्सटेंस, एंड मोल में क्या होगा? फॉर 1 मोल। Is that clear? So, please tell me.
Yes.
ठीक है, यहाँ पे सुनिए, specific heat capacity SHC will be equal to the Q divided by delta T, and you will multiply it by the mass in grams. For Cm, you will have Q upon delta T as before, multiplied by moles, number of moles. Everyone done writing? Yes or no? Please tell me.
Yes.
सिद्दीका, सिद्दीका समझ में आ रहा है आपको? हम तो भूल ही जा रहे हैं, आप हैं क्लास में, आपका कैमरा ही नहीं ऑन है। सिद्दीका, आपको समझ में आ रहा है?
Yes, sir. Yes, sir.
ठीक है, आप ऐसे हाँ ना कुछ तो बोलते रहिए, ठीक है, अदरवाइज हम भूल जाएंगे कि आप क्लास में।
Okay, sir.
All of you done writing? Yes or no? Please tell me. Done writing?
Yes, sir.
थोड़ा माइक ऑन करें, एक दो सवाल हम पूछना चाहते हैं, थोड़ा माइक ऑन करके रखिए आप लोग, ठीक है। ध्यान सुनिए, एक चीज पढ़ी थी, अरे माइक ऑन तो करो, थैंक यू। एक चीज हम लोगों ने पढ़ी थी, एक्सटेंसिव एंड इंटेंसिव, याद है?
Yes.
We learned ना, एक्सटेंसिव एंड इंटेंसिव। एक्सटेंसिव मतलब अगर मास बढ़ता है तो वो भी चीज बढ़ जाती है ना, इट डिपेंड्स ऑन
Yes, sir.
मास, ठीक है। इंटेंसिव इट डज नॉट डिपेंड्स ऑन मास, इट डज नॉट डिपेंड ऑन द अमाउंट ऑफ द सब्सटेंस, ठीक। नाउ व्हेन वी आर टॉकिंग अबाउट हीट कैपेसिटी, जब हम बात कर रहे हैं किसके बारे में? हीट कैपेसिटी,
Heat capacity.
तो आप कम पानी लीजिए तो हीट कैपेसिटी कम, ज्यादा पानी लीजिए तो हीट कैपेसिटी ज्यादा, बात सही है?
Yes, sir.
तो हीट कैपेसिटी विल बी एक्सटेंसिव, हीट कैपेसिटी इज एक्सटेंसिव, ठीक,
Yes,
Yes,
sir.
sir.
करेक्ट है? ओके, थैंक यू Siddiq. Now please remember, if I talk about SHC, specific heat capacity, or मोलर हीट कैपेसिटी, तो इस केस में वी हैव चेंज द डेफिनेशन ऑल टुगेदर ना. स्पेसिफिक हीट कैपेसिटी इज द amount of heat required to increase the temperature by 1 degree Celsius of 1 gram of substance. तो अब समझिए, if we are talking about 1 liter water, we are talking about 1 liter water, or we are talking about 1000 liter of water, or we are talking about 1000 liter of water, पानी तो पानी है, उसके SHC में कोई चेंज नहीं आएगा, because we are taking only 1 gram into consideration whenever we are calculating specific heat capacity. समझ में आई? Because we are
Yes,
taking
sir.
only 1 gram, and यहाँ पे we are only taking 1 mole. We are only taking how much? We are only taking 1 mole. That is why these two things will be intensive. These does not depend on the amount that you are taking. आपने बोला कि पानी का हीट कैपेसिटी कितना है, तो ऑब्वियसली वहां पे we are not mentioning ना that it is specific or molar. In that case, you will have extensive property when we have defined कि 1 ग्राम के बारे में बात कर रहे हैं, or if you have defined that we are talking only about 1 mole, then in that case it will be intensive. It will not depend on the amount, rather it will depend, for example, पानी का heat capacity, पानी का specific heat capacity, it will be some number. No matter how much water you are going to take, the specific heat capacity of water will be same. Similarly, if I talk about, let us suppose, the specific heat capacity of oil, okay? The specific heat capacity of oil, it will be, specific heat capacity will be same, no matter you are taking 1 liter or 2 liters of oil. Is that clear? As one of, please tell me.
Yes.
Yes, sir.
चलिए अब इसी पॉइंट को लिख लीजिए ध्यान से, बिकॉज एक्सटेंसिव एंड इंटेंसिव इट इज अ ओल्डर कंसेप्ट, 2-3 क्लास हो चुके हैं, इस वजह से हमने अलग से यहाँ पे समझाया. प्लीज राइट हियर, हीट कैपेसिटी is extensive property, but specific heat capacity and molar heat capacity is intensive property. All of you done writing? लिख लिया? एक लाइन है.
Yes, sir.
Now again we have the same conflict of constant volume and constant pressure. So when we measure the heat capacity, at constant volume, horizontal, at constant volume, and we can measure it at constant pressure. Constant volume में जब measure करते हैं heat capacity को, it is known as CV. Constant pressure में measure करते हैं तो we know it as CP. ठीक है, ध्यान से. We have seen, आपने देखा था Q it is equal to C delta T, है ना? So वही हम लिख रहे हैं, ध्यान से देखिएगा. Heat capacity at constant volume it is equal to CV delta T. Heat at constant pressure it is equal to CP delta T. ठीक है? Is this clear? Yes or no? Please tell me. कितना?
Yes, sir.
अब ये बताइए, what is heat at constant volume? Last class के हिसाब से बताइए, what is heat at constant volume? What I can write heat at constant volume? It is equal to, last class के हिसाब से बताइए, when delta V it is equal to 0, heat at constant volume it is equal to, दिखाइए, बोलिए भाई, जल्दी बोलिए. Heat at constant volume. नहीं मिला किसी को. Constant, when we have constant volume process, constant volume मतलब कौन सा प्रोसेस? आइसो. हाँ, तो आइसोकोरिक में क्या होता है? आइसोकोरिक में क्या होता है? QV it is equal to how much? अरे रे रे, अरे रे रे, डेल्टा यू ना अभी तो कराया थोड़ी देर पहले भी, यही ध्यान रखना है. Is this clear? This is the thing
Yes,
that you
sir.
have to guys remember. Yeah, this is very important. Okay, you have to remember this by heart. So this is again what? This is nothing but it is equal to delta U. And what is heat at constant pressure? What is heat at constant pressure? Arey, heat at constant pressure. Oh my God, heat at constant pressure. बोलो भाई जल्दी. Heat at constant pressure. It is equal to
Q by delta T into
मरियम, सिद्दीका. सिद्दीका ने तो लास्ट क्लास की नहीं थी. मेरा सिद्दीका को. अरे अभी तो कराया भाई. देखो ना नोटबुक तो देखो. स्क्रीन देखने से क्या होगा? नोटबुक देखो. At constant pressure, heat involved at constant pressure क्या बोलते हैं उसको? ना 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 ना.
Delta H.
सॉरी, डेल्टा
Delta H.
H. एंथैल्पी. आज का टॉपिक था सबसे पहला, एंथैल्पी. What is the first line that we wrote? Heat involved during a change when external pressure is constant. है ना? तो सब भूल गए आप लोग. So when we are measuring the heat capacity at constant volume, it is CV, and constant pressure पे CP है. Right, next, which is very important topic, they can give you this particular derivation in your exam, the relationship between CP and CV. Please see here guys, delta H, we know that is equal to delta U plus delta NGRT. Delta NGRT is right. For delta Ng, it is equal to 1 mole. If delta Ng it is equal to 1 mole, then I can write it as what? Delta H is equal to delta U plus 1 RT. So I can ignore the 1. Then what I will do, I will divide the whole thing. See, delta H I can write it as CP delta T. Delta U I can write CV delta T plus RT. I will divide the whole thing by delta T. Divide by delta T. And we will get CP, it is equal to CV plus R. Or if I write it like this, CP minus CV, it is equal to R. So this is the relationship, but the condition is you should have 1 mole of gas. CP minus CV, it is equal to R.
Sudden.
Anyone still writing? Please let me know. Is everyone done?
Yes.
Yes.
Okay. Okay. Another derivation that you can see is, please see here. Delta H, it is equal to delta U plus, if you remember, it is also equal to P delta V. Correct guys? Yes or no, please tell me.
Yes, sir.
Please see. Now we can write this as P delta V. This is equal to NR delta T. Now we are not talking about gases here. Okay? We are not talking about gases. This can be for anything. P delta V, the change in volume is because of the change in the temperature. Now I can write delta H as what? Cp delta T. Delta U as Cv delta T. Plus I can write NR. Plus I can write NR delta T. Now here also we have the same thing. Here also we are going to have the same thing. Let and it is equal to 1 mole of gas, and divide by delta T, you will get Cp is equal to Cv plus, you will get what here? Delta T will be divided, you will get only R. You have 1 mole. So this is Cp minus Cv is equal to R. Is this clear, guys? Yes, no, please tell me.
Yes. Sir, done.
Now, right next. Right next here. Measurement of heat. Okay. Measurement of heat. Now we have talked about, see, we are talking about enthalpy and everything, right? Enthalpy is what? Enthalpy is nothing. It is the heat involved in a particular change. Now we have seen that heat capacity also. We have seen enthalpy also. We have seen the heat change at constant volume. We have seen the heat change in constant pressure also. Now we have to know about how to measure heat. How to measure heat, and there are only two ways that you have to remember. First one, it is known as coffee cup calorimeter. Don't write anything like that. Okay, one is coffee cup. Don't write, please don't write. Okay, calorimeter. And the another one that you have to know is bomb calorimeter. The main difference between coffee cup calorimeter and bomb calorimeter is that coffee cup calorimeter, it measures at constant pressure, and bomb calorimeter, it measures at constant volume. इतना याद रहेगा, हाँ या ना, जल्दी बताएं, है ना? ठीक है. That means I can say that whatever heat you are measuring in coffee cup calorimeter, whatever heat you are measuring with coffee cup calorimeter, it is what it is. At constant pressure equal to what? Enthalpy ना? Enthalpy, हाँ या ना? याद नहीं याद है? उम्मीद, हर्षा, मरियम, नहीं याद? Okay, let's start. Wait a second. Am I audible, guys? मेरी आवाज
Sir, before
Thank
your
you.
नहीं आ रही. Madam, am I audible?
yes, sir.
Harsha, Harsha, you have to make me host. Thank you. Just a second. My internet actually is not this. Am I audible properly now? Is my screen
Yes,
visible?
sir.
सब सही है?
Yes, sir.
Yes.
ठीक है. Okay, you can keep your cameras on right now. ठीक है. So QP it is equal to delta H, right? QP it is equal to delta H because heat measurements at constant pressure. मेरा ये कैमरा ऑफ हो गया. Bomb calorimeter. This measures at constant volume. So QV, this will be equal to how much? Whatever heat is measured by bomb calorimeter, it will be equal to what? Delta. भूल गए, फिर भूल गए. हर्षा, अब्दुल हमीद, मरियम, सिद्दीका. Heat at constant volume, it is equal to. नहीं याद. हर्षा, what happened? नहीं याद हर्षा.
So delta U.
हाँ, डेल्टा U. So bomb calorimeter आपको देगा डेल्टा U. Coffee calorimeter आपको क्या देगा? डेल्टा H. If they say they will never tell you that it is coffee cup. They will tell you that when the heat was measured at constant pressure, it was found out to be that much. So वो किसकी बात कर रहे हैं? डेल्टा H की. When they say at constant volume, they किसकी बात कर रहे हैं? डेल्टा U की. इतना समझ में आया? हाँ या ना?
Yes, sir.
क्लियर है सबको? हाँ या ना? जल्दी बताएं.
Yes, sir.
ठीक है. अब सुनिए, यहाँ इतना ही काफी है आपके लिए. यू डोंट हैव टू वरी अबाउट दी डायग्राम्स की कॉफी कप कैसा दिखता है, बॉम्ब कैलोरीमीटर कैसा दिखता है. फोटो देखना है, आप अच्छे से चले जाइए एनसीईआरटी. इन एनसीईआरटी यू विल सी द पेज नंबर 169. पेज नंबर इज 169. वहां पे आपको बहुत अच्छे से खूबसूरत डायग्राम बना हुआ है बिल्कुल. यू कैन इजिली सी व्हाट इज कॉफी कप कैसा दिखेगा और बॉम्ब कैलोरीमीटर वाला कैसा दिखेगा. इज दिस क्लियर? यस और नो प्लीज टेल मी गाइस. ठीक है. अब सुनिए ध्यान से. वी आर गोइंग टू डू अ क्वेश्चन. क्वेश्चन आपके बहुत हार्ड. क्वेश्चन आपको ऐसा लगेगा ओ माय गॉड क्या ही पूछ दिया. ठीक है. देयर इज वन क्वेश्चन. But all of these questions are not very easy. Questions are very huge and all. But sorry, if you see exactly what is happening, तो आपको लगेगा अच्छा ठीक है बहुत ही आसान है, कुछ नहीं हो रहा है यहाँ पर. Here guys, this is a question from NCERT itself. 1 gram of graphite. ध्यान से देखिएगा. 1 gram of graphite. Graphite is what? Graphite means. अच्छा यहाँ पे दिया हुआ ना. तो graphite means carbon. ये दिया हुआ है. Graphite is burned in a bomb calorimeter. What they have given? Bomb calorimeter. In excess of oxygen at 298 Kelvin and atmospheric pressure 1 according to the following equation. According to the following equation. इतना इन्होंने दे दिया. ठीक है. Then they are saying during the reaction temperature rises from 298 Kelvin to 298 Kelvin to 299 Kelvin. Clear है हाँ या ना? If the heat capacity of bomb calorimeter is 20.7 kilojoule per Kelvin, what is the enthalpy change for the above reaction at 298 Kelvin and 1 atm? ध्यान से सुनिएगा what they are trying to tell you and what they are trying to ask you guys. First of all, यहाँ पे हम लोग ने देखा, this is my reaction. Let us leave the reaction right now. They are talking about bomb calorimeter. Calorimeter. बॉम्ब कैलोरीमीटर का मतलब क्या हुआ? डेल्टा यू. बात सही है हाँ यार? जल्दी बताएं. दिस मींस डेल्टा यू. हाँ या ना?
Yes, sir.
ठीक. and they are saying that delta U, ठीक है. Now also इसका मतलब ये हुआ they are talking about QV, सही है.
Yes, sir.
ठीक है ना. आप सुनिए यहाँ पे we have also seen QV will be equal to CV into delta T. Now the heat capacity of bomb calorimeter हमने कितना बनाया हुआ है. Bomb calorie heat capacity is 20.7 into 10 to the power 3 joule per Kelvin. यहाँ तक ठीक है, कोई दिक्कत
No, sir.
नहीं. अब यहाँ पे आपके पास सुनिए ध्यान से, this is the heat. अब ध्यान सुनिए, what happens in a bomb calorimeter is how we are measuring all of these things. पहले तो आप ये बताओ, bomb calorimeter has this much heat capacity. This is my system. इसमें तो कोई किसी को शक नहीं होगा ना. This is your system, सही है.
Yes.
अब्दुल हमीद, ठीक है. This is your system. Now system will be, what is happening to the system? System में हो रहा है combustion. Can you see combustion happening in the system? दिख रहा है combustion? अब्दुल हमीद, हर्षा, all of you guys, सिद्दीका, मरियम,
Yes, sir.
Yes, sir.
दिख रहा है combustion. So combustion में क्या होता है? Heat will be given out. Heat is given out, है ना? Heat is given out. Heat is given out to what? This complete thing is happening inside bomb calorimeter, and when this particular combustion is happening, तो heat बाहर जा रहा है. Heat बाहर जा रहा है, and that is why the temperature of bomb calorimeter it is increasing from 298 to 299 Kelvin. Now, if we are talking about the system, ध्यान सुनिएगा. If we are talking about the system, heat is given out. Heat is given out. That is why I will write delta U. एक काम कीजिए यहाँ पे, एक चीज आप है भूल गए यहाँ पे, इनटू डेल्टा टी कितना है, 1 केल्विन का है ना. डेल्टा टी इज 1 केल्विन, वो हम भूल गए थे. ये लिखिए आपने डेल्टा के 1 केल्विन, ठीक है, ये हम भूल गए थे. तो केल्विन और केल्विन को काट दीजिए, तो डेल्टा यू दैट इज इक्वल टू क्यू इंटू वी विल बी इक्वल टू, ध्यान से सुनिएगा, -20.7 इंटू 10 टू दी पावर 3 जूल्स, या फिर आप इसको लिख सकते हैं -20700 जूल्स. माइनस साइन समझ में आया? बिकॉज हीट इज गिवन आउट बाय द सिस्टम. Heat is given out by the system, that is only increasing the temperature. That is why we are taking it as negative. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
किसी को कोई दिक्कत? किसी को दिक्कत नहीं? ठीक. अब ध्यान से चलते हैं हम लोग डेल्टा. अच्छा, दिस इज, अच्छा एक काम करते हैं, इसको अभी आप ऐसे रहने दीजिए, डेल्टा यू मत लिखिए इसको, है ना. क्यू वी कितना हो गया आपके पास? -20700. ठीक. नाउ लेट अस मूव ऑन टू डेल्टा यू. जो डेल्टा यू कैलकुलेशन हम लोग, नाउ व्हेन आई टॉक अबाउट combustion, yeah, for 1 mole of combustion, of graphite, if you are taking 1 mole of graphite and we are combusting, if you are taking 1 mole of graphite and we are combusting, then what we can say? पूछा क्या है इन्होंने? Enthalpy change for the above reaction. अच्छा अच्छा ठीक. आपको सुनिएगा, 1 मोल क्यों ले रहे हैं सर, देखिए यहाँ पे. In this particular reaction, they are asking me what is the enthalpy change for the above. For the above, बताइए क्या दिया हुआ है?
Reaction.
रिएक्शन. इस रिएक्शन के बारे में बात हो रही है ना. अब ध्यान से देखिए, यहीं पे जो थर्मोडायनेमिक्स है ना, थोड़ा सा कॉम्प्लिकेट हो जाता है. We have done only the combustion of 1 gram of graphite. We have done only the combustion of 1 gram of graphite. We got some data. From this data, we want to calculate the enthalpy change or the heat change in this particular reaction. इस रिएक्शन में आपके पास है 1 mole of carbon, which is combusting with 1 mole of oxygen to give you 1 mole of carbon dioxide. तो जो enthalpy change पूछ रहा है, ये वो किसके लिए पूछ रहा है? For 1 mole of graphite. ये बात समझ में आई आपको, हाँ या ना, ये बताएं.
Yes, sir.
ये समझ में आया? हर्षा, हर्षा हाँ
Yes,
ना
sir.
कुछ तो बोलो, हाँ या ना.
Yes, sir.
पक्का?
Yes.
ठीक. Now, this much heat was released when we did how much? When we had 1 gram of graphite. When we had 1 gram of graphite. So for 1 mole of combustion of graphite, आपके पास जब for 1 gram, आपके पास for 1 mole के लिए कितना जाएगा ऐसे? It will be equal to minus 20700 into क्या करते बताइए? Into 12 कर दे, because 1 मोल में
Yes,
कितना होगा? 12 ग्राम ऑफ ग्राफाइट. 12 ग्राम होगा ना. कार्बन का मोलर मास कितना होता है? 12. So this will be equal to how much? 207 into 12. कैलकुलेटर कहाँ गया? कैलकुलेटर. 207 multiplied by 12. It is equal to 2484, and then we have 3 zeros. इतना क्लियर सबको है ना?
yes, sir.
ठीक है. माय zeros are fine ना. वहां पे 2 जीरो था. अच्छा एक सेकंड, थोड़ी गलती होगी. 2 जीरो रहेगा. We had here 2 zeros ना. 20700. हाँ. So this will be इतना joules. This many joule of energy will be there. Joule, and because it is in per mole, so it will be joule per mole. Now this is the delta U for 1 mole of combustion of gas. अब इसके बाद सीधा आपको क्या करना? Delta H is equal to delta U plus what we are going to do? Delta Ng RT. Delta Ng RT. Now you can see what is the number of moles of gas. Number of moles of gas. Here also 1, here also 1. Number of moles of gas, it is equal to what? Number of moles of gas, it is equal to Np minus Nr. Product में भी 1 है, reactant में भी 1 है. So this will be equal to 0. Correct, guys? So we can write delta H will be equal to delta U, which will be equal to how much? Minus 248.4 kilojoule per mole. Is this clear? ठीक है. इस तरह के आपके पास सवाल होंगे. You have to read the question very carefully. Things are going to be easy, but हाँ, मिस्टेक होने के चांसेस बहुत ज्यादा हैं. मिस इंटरप्रेट करने के भी चांसेस बहुत ज्यादा है ना. कि बहुत छोटी छोटी चीजें हैं. That how did we get 1 mole of graphite? क्या क्यों हम लोग कैलकुलेट करने लगे? Because they are asking about the reaction. They are not asking about 1 gram. कि उस पर्टिकुलर उस वहां पे पर्टिकुलर बॉम्ब कैलोरीमीटर में क्या हुआ? They are talking about the reaction. That is why we are taking 1 mole. Please write this down. Dika, let me know once you're done writing. Done. So guys, if you are done writing, let me know. Mariam, Harsha, Martin, done?
Yes.
Done, sir.
ठीक है. So that's it for today. Siddika, you will be in the class, ठीक है ना? बाकी you guys can leave.
Sir, I actually have to go out, so it's okay. I'll study for my course first.
हाँ
The
चलिए ठीक
lab
है.
math.
बाहर जाना है. बाहर जाना है बस आपको, है ना?
Yes, sir.
फिर क्या